Hello everyone, my name is Satveer Kaur and this is our business intelligence project and my group members are Simranjit Kaur and Chamandeep Singh. In this project, we analyze intergalactic crime data using Power BI. The objective was to clean and prepare the data, design a star schema, create DAX measures to analyze total hours, overtime, and reporting patterns, and build dashboards to uncover operational insights. I'll walk through the data preparation steps, the data model, the measure created, and finally the dashboards and key findings. For our first step, which is data cleaning and preparation Power Query, we begin by importing the CSV file into Power Query for data cleaning and preparation. Here, first we remove for first step we imported the CSV file. Here you can see incident staging, and we removed all the null columns from the file. Empty columns that were generated during the CSV import. We also removed fully blank rows to avoid incorrect aggregation later in the analysis. As you can see here, it shows removed blank rows. Next, we standardize column name as correct data types. As you can see, like date has date, a rank ID is created for a whole number, the data type change, officer rank text data type, lactic force ID is whole numbers. So we corrected each and every column's data type. Date fields were converted to date format, time fields to time format, and numeric fields such as total hours and overtime hours were converted uh, to decimal numbers. As you can see here, they are converted into decimal numbers. Total time taken hours including OT hours. For data quality, overtime hours that were missing were replaced with 0. Here you can say all the zero values, it was missing values in the overtime hours. And since no overtime was recorded for those incidents, however, missing reported time values were left as null to avoid assigning artificial hours. In the time incident report, we have null values, so we leave it as it is. These null values were handled at the visual level later. um, we didn't change the null values to avoid assigning artificial hours. During dimension creation, we ensured that all dimension keys were non-null and unique. Duplicate values were removed only from these dimension tables, never from the fact table. For dim date, for example, we take date column as a reference from fact incidents. We created date key for this, and then we converted its data type to whole number. And for other columns, we use add column function, and we use date as a reference to create year column, month, quarter, week, and day for dimension date. And for others as well, we took a reference from incident staging, and we took the column and we removed all the duplicates and null values, so we can get clean data for our data analysis or for creation of star sigma. So after cleaning the data and from the transform data, we go to model view, where we design our star schema design. Here in this, uh, the central fact table is the fact incident, which contains one row per incident, and along with numeric measures such as total hours and overtime hours. So surrounding the fact table are dimension table including date, time, dim force, dim incident, dim rank, dim response. Each dimension contains unique keys, and all relationship was defined as one to many with single direction filtering from dimension table to fact. As you can see, We created all the relations with the fact incident table using many to one relationship. So all the dimension tables were interconnected with a fact incident table. This structure ensures accurate aggregation, improves performance, and follows BI best practices. After creating star schema, uh, we created DEX measures to support the required analysis. We created measures for total hours, as you can see here, and overtime hours using sum function, and then total hours and overtime hours using sum function, and then calculated the percentage of incident by hours. This was done by removing only the hour filter context while keeping the classification context intact. We also calculated the percentage of hours due to overtime using divide function. As you can see here, we created the percentage hours by classification per date. We created total hours and percentage of overtime by using divide function. We also created advanced measures using DEX function not covered in class. These include the median total hours and 90th percentile of total hours, which help identify typical versus worst case incident duration. As you can see here, 90 using the percentile, here we calculated the 90th percent of total hours, and here median total hours. And after creating the DEX measures, we go in report view, and for our first dashboard page provides an operational overview. It displays total hours, overtime hours, and the percentage of hours due to overtime using KPI cards, slicer for date, incident classification, and location. Allows user to interactively filter the analysis, like data for certain date you can see, or using incident classification as well, you can choose the data. Here overtime hours by incident classification, I calculated how the hours how many overtime hours have each incident classification. And for our second dashboard, the second page shows the distribution of workload by incident classification over time. Here we show the count of incident uh, reported, and this visualization displays the percentage share of total hours for each classification by date, allowing us to compare how workload shifts across incident types. Like here you can see Imperial Legal Code has more workload than MISC, and as you can see the others have very least percentage, like Imperial Legal Code traffic has very least workload during those days. And our third dashboard shows we show the count of incidents by reported hours and classification, as well as the percentage distribution of incidents by hours. This page helps identify peak reporting hours and operational pressure points. And for the table, we display median, the 90th percentile incident resolution time by classification. Sorting by the 90th percentile highlights classification with extreme resolution duration, which may indicate operational bottleneck. In conclusion, this project demonstrates how a star schema, DEX measures, and effective dashboard design can be used to analyze operational data The analysis highlights overtime impact, workload distribution, and reporting patterns supporting data driven decision making. Thank you.